Assalamualaikum and greetings everyone. I am NURFARHANA and I will be moderating the forum today. In this forum, we will be discussing the difference between three methods in assessing species distribution, which are extent of occurrence EOO, area of occupancy AOO, and ecological niche model ENM. The comparison will be made based on the distribution of three different species consisting of Colocyrus prevesti, Cyanopetrus pecoritis, and Megaphyrus nasuta. First and foremost, let me introduce the panels for today's forums. First panel, Mrs. ARMAN. Second panel, Miss CLARA. Third panel, Miss FARHANA, and fourth panel, Miss ZAKIRAH. Without further ado, I would like to invite Mrs. ARMAN to briefly define EOO and AOO and ENM.
Thank you, our moderator, for the welcoming speech. So, for the extent of occurrence, also known as EOO, can be defined as the area contained within the shortest continuous imaginary boundary, which can be drawn to present all the known, inferred or projected site of present occurrence of a taxon including cases of vagrancy. On the other hand, for AOO, area of occupancy, is a scale method representing the area of suitable habitat currently occupied by the taxon. For the third one, ecological niche model, ENM, is a method that uses occurrence data in conjunction with the environmental data to produce correlative model of the environmental condition that favor a species, ecological requirements, and predict the relative suitability of a habitat.
As for the difference, EOO and AOO are processed using the Geocat software, while ENM use the Maxent software to analyze the data. Although using the same software, which is Geocat, EOO needs at least 3 point data processing, while AOO needs a minimum of 1 point and scale using 2 × 2 km per 2.2 km grid per cell. To produce an ENM using Maxent and data from GBIF, a minimum of 12 points is required. Both EOO and AOO are processed by using location point only, resulting in EOO producing an overestimate species distribution and AOO producing an underestimate species distribution. ENM, on the other hand, are processes combining the location point and environmental data. The map produced will show a suitable distributional range based on the environmental data, including the hotspot location that favor the survival of the species.
Okay, thank you, our moderator. So, AOO, area of occupancy, can be defined in simple words as occupied areas. So, it is using a scale of 2 × 2 km grid, which is a default reference scale, and which is to comply and to ensure valid use of the criteria and to maintain consistency of REDDIS assessment across taxa, which is to comply with the IUCN REDDIS criteria. So, the area value of AOO can be compared based on the thresholds set in the criterion B2, which are more than 10 km square is considered critically endangered, while more than 500 considered endangered. More than 2,000 km square is considered vulnerable, while more than 4,500 is considered near threatened. And based on the three species, we are going to compare Bravo squirrel, which is a Colocyrus bravosti, have AOO value of 68 km square, while the Cyanopetrus pecoritis have value of 52 km square, and Megaphyrus nasuta has a value of 48 km square. And if we look into the threshold set in criterion B2, all the species should be fall into the critically endangered criteria. But based on the result produced by the Geocat, all the species fall into the endangered criteria. So I guess that's all. Thank you.
Thank you, Ms. FARHANA, for the explanation. Next, I would like to ask Ms. ZAKIRAH to compare the EOO distribution model produced for each species.
Okay, thank you, Ms. Najwa, for the question. So as Ms. Clara stated before, EOO is a minimum convex polygon drawn around the available distribution points for a species. So in this case, you can see from each of the posters we've chosen, it is the polygon consisting of the outermost points in the map. The EOO for the three maps are different depending on the distribution of the points for each species. As with AOO, like Ms. Farzak stated earlier, they have some criteria and ratings that can classify a species as from critically endangered to near threatened based on their EOO. So for the ratings, actually all three of these consist of near threatened species. We can see for the squirrels, Brevo squirrels, we have an EOO consisting of 67,945 kilometers square. That is by far the largest EOO for each species that we have chosen for our forum. The second largest EOO for our forum belongs to Megophrys nasuta, the Malayan horned frog, with a value of 31,244 kilometers square. And we can see that the least value for EOO belongs to Cynopterus brachiotis, which is 30,959 kilometers square. As I've said before, we can see that all three species fall under the range of near threatened. However, the extent of occurrence cannot be trusted blindly. It often overestimates the species population and distribution. Thus, species range maps based on EOO are used for various analyses. However, it must be used with a grain of salt in our mind, as they are usually highly interpolated. This can cause our results to become biased, and therefore it's not really suitable for us to rely on EOO alone.
So I would like to add in my point regarding the EOO, area occupancy. So as for EOO, it's there is overestimation, right? So for EOO, there is underestimation happen there, because it seems that they use the 2 times 2 kilometer grid. So it consider that the species is only occur in that area. So I guess we should expand the grid so that we can. So there is because there is a probability that the species also occur in much wider area. So that's why the AOO is considered underestimated. So I guess that's all. I pass to the moderator.
Zakirah for the explanation. The output of ecological niche modeling consists of several pictures and graphs including the reservoir operating characteristic, curve for the same data average over the replicate and pictures of the model. Every ROC curve process and its own AUC value such as 0.0 until 0.5 equal poor, 0.5 until 0.7 moderate, and 0.8 and 1.0 is good. Hence, I would love to invite Mrs. ARMAN to further compare the AUC values of each species.
Thank you, moderator Najwa, and thank you for the enlightenment in the definition of ENM. So I'm going to compare the AUC values. Okay. We have three models. Callosaurus previously, which 0.7 value, Cynopterus brachiotis 0.8, and Megophrys nasuta 0.7. As we can notice, 2 out of 3 have 0.7 value, which indicate moderate quality of the model, while for the bad one, the bad species 0.8, which indicate good model. The value may differ due to different species needing different environmental layers, but all of this calculation was run by just using the same environmental layer, which are bioclimate 1 to 9. Terrestrial species such as squirrel and horned frog may need to focus on elevation layer or any ground focus layer, while volant or flying species like bats need to focus on wind velocity and other on air layer to get more precise model.
ARMAN for the explanations. Clara, as we can see, the map contain many colors. What do they resemble? How do they help in understanding the species model?
Thank you, our moderator. So for the maps are produced in color gradient to indicate the probability that conditions are suitable, with red color represent high probability of suitable condition for the species. And then for the green color is represent condition typical of those where the species is found, and lighter shade of blue represent low predator probability of suitable condition. So for the distribution of Nasuta for the distribution of Megapress Nasuta in Peninsular Malaysia, the most suitable region for Megapress Nasuta are in Penang and Kedah. This species is most commonly found in the western part of Peninsular Malaysia and is rarely found and less suitable in the eastern part of Peninsular Malaysia. So I wonder how about the other species.
Right, so for Calloceus pravosti, the Pravostura, based on the model produced by the Maxent software, it seems that this species prefer the area, the east coast of the state of Pahang, and also small patches of the Perak and also the states of Selangor. And it seems that the green area, which is indicate the typical area of where the species is found, is also quite consists of small region, which is also at the east coast of Pahang, states of Perak and Selangor. And the blue area, which is the maximum, I guess, which dominate most of the region in the Peninsular Malaysia, indicating that most of the area in Peninsular Malaysia have the low predicted probability of suitable conditions for Pravospora. And I guess what about the Cynoturus brachychaetes?
Well, actually, for my chosen species, it actually has quite a different map compared to both of yours. You can see that for my species, there is actually quite a lot of dark blue, especially in the regions where Kelantan and Terengganu, as well as some parts of Pahang is located. Since there is quite a range from dark blue to actually a bit of red right there, you can see that Cynoturus brachychaetes is actually predicted to have a high suitability in inhabiting areas, especially in areas such as like Selangor and near Negeri Sembilan. So we can see, actually there aren't many points in GBIF when I downloaded the data. So this could actually be redundant or wrong, but from the results of the Maxent process, this is what we get. It has some green patches here and there from Perak until about to Malacca and some parts of Johor, but it seems mostly concentrated in Selangor, Negeri Sembilan and Malacca, with Terengganu being totally out of the way for this species to inhabit that place.
And I want to add, actually, my species is considered least concerned in the IUCN red list, and only near to written in the red list of mammal. But in the map and the model produced, it seems that this species have a very limited and isolated places where it's distributed, because this species actually can one of the squirrel species that can be seen everywhere, one of the most widespread. But based on the model, this is the result we get. And maybe because of the point in GBIF, I guess the point is not updated, and maybe there is a redundant that we are not aware. So what about?
I'm sorry, but yeah, it could actually be because we've only done the map for Peninsular Malaysia,
We don't consider.
And the IUCN status considers the species worldwide.
Yeah, worldwide. And what about Megaphilosita? If I'm not mistaken, this species is considered one of the rarest, right? But based on your model, it has very wide distribution.
Maybe because Megapress Nasuta can adapt to
environmental changes.
Lots of what range of habitat?
Yeah.
Oh, I guess that's why the model is like this. Yeah. So I guess that's all. Anything else?
For enlightening us with your explanation. With this, our forum comes to a close. All of our moderators have done a great job explaining and helping us in understanding the species distribution model, as well as comparing EOO values and AOO values and ENMs using the Geocat and Maxent. To complete ecological niche models, are a suitable and preferable method in helping to assess the species distribution across the map and their habitat preference. The usage of software such as Geocat and Maxent as well as databases of such models, one needs to be mindful of the bias and problems that can occur, such as overestimating and underestimating the species chosen. Thus, further knowledge and understanding need to be explored more to create more precise data. That is all for today. Thank you for joining us today and thank you.